Uh, I'll start by sharing my screen. We'll go through the agenda and then through the demos. Okay, so we have two agendas here. One is about the Helm charts, OpenEBS Helm charts with the issue number 1171. So this is where we want some contributors' help. We already have a Helm chart in an OpenEBS repository. If you can see my screen, one is to navigate to the K8S charts OpenEBS folder, and one will find the Helm charts here with the descriptions. What we ideally would like to do is take this and submit a PR to Kubernetes charts. And that would help us get in line with the way Kubernetes proceeds with various chart deployments, Helm charts deployments. So OpenEBS would be one of them. That would help end users as well. So this is something, it would be great if we can have any contributors coming out to help us submitting this PR. One requires a basic understanding of Helm deployments and Kubernetes to get around this issue, to submit a PR for this particular issue. Okay, so the second one is with regards to the demos. I shall be getting on with these demos one by one, and the code for these demos is available in OpenEBS community repo. This is a new repo that we have created, and this will have the demos, tutorials, as well as the proposals from the community regarding, it will have the proposals for all the projects within OpenEBS. And if you are able to see my screen, this is the demo that is 16th of February 2018. And I have listed down some of the readmes. Okay. All right. So the basic assumptions that we go before this demo is we are using OpenEBS Maya project's master branch for this particular demo. This master branch has got volume policies, which has not yet been released. So anybody who would like to try out the volume policy would need to use the master branch as of now, the OpenEBS Maya's master branch. All right. So the other assumption is we need a Kubernetes setup. For this particular demos that we will be running through, a Minikube will be sufficient. And the third assumption that we have for this demo is basic knowledge of some of these Kubernetes kinds. For example, a storage class, custom resource, config map, deployment, as well as a service. These are some of the things we will be seeing in this particular demo. Fine. We'll start off with the first demo, that is with respect to the storage pool, configuring a storage pool using a volume policy. Okay, so we have discussed already about storage pool in our earlier meetings. This is a custom resource that is exposed by OpenEBS, and using it, an operator or a user can provide a persistent path for an OpenEBS volume. The persistent path can be on can be on the host or the node, the Kubernetes node, or it can be a mounted disk. So we'll go to this demo. If you see this particular folder, 16 Feb 2018, it has got a set of YAMLs. These are the YAMLs we'll be running in order to create the demo. So to start off configuring storage pool, we'll be using these YAMLs. And just go to my setup. All right. So this is the setup that I have, and this is a Minikube setup. If you run it, kubectl version. So I'm running on 1.9 version. 1.9.2 is a client, is my client, and 1.9 is my server. Right. So I don't have any of the resources here. If you see, it doesn't have anything. It has got the Kubernetes service up and running, and it has got the default, let's say, storage class, right? Okay, and I'll just run something called VP. Okay, if I do this, it will say this Kubernetes or the server does not have a resource type called VP. That is understood because VP is something that OpenEBS exposes. VP is a alias or the short form of volume policy. We'll be talking about this. This is again another terminology that OpenEBS exposes. SP is about storage pool. This is the shorthand notation or the alias form for storage pool. Right? This is again a custom resource that OpenEBS exposes. Right, and let's check some of the service accounts. Okay, so we have got the default service account that comes predefined with the default with the installation of Kubernetes, which is Minikube here. Right. Okay, so what we shall do is we shall run some of the operations now to set up the storage pool. Okay, the first thing that I would do is I would run the operator. We'll see what the operator contains. Right. So if you see, it has got installed the Maya operator as a service account, OpenEBS Maya operator, and it has got a bunch of role bindings, a cluster role as well as a cluster role binding. These are required because the API server, which you can find out here, the deployment Maya API server, this requires to invoke the Kubernetes APIs. And in order to do that, it needs to have some authorizations, which are being provided by these three resources, right? Cluster role, cluster role binding, and then giving those roles to this particular service account. Okay, all right. So yeah, so this is something we were talking of. There is something called storage pool claims. There is something called storage pools, and then the last one is known as volume policies. So these are three custom resources OpenEBS has exposed as of now. Among these, we'll be talking about storage pools and then the volume policies. Others, for example, the storage pool claims, we'll be talking of later in some of the demos. Right. Okay. And I've already discussed about the Maya API server. This is the OpenEBS API service. It exposes some REST endpoints. This in turn invokes Kubernetes APIs to create deployments or create pods and so on, list the custom resources and so on. Right. Now, if you see, we'll just do some verifications. We have a deploy, we have a deployment, we have a pod. This is the Maya API service pod. And all right, so till now we don't have any extra storage classes defined here. This is all, the one that we see here is the standard one that is provided from Kubernetes, right? So this is a service account. We see a new one has been added, right? The one that was installed via the operator. Okay, and we'll see the service here. Again, we find a new service, that is a MyAPI service. It exposes a IP, and we'll see how we have to use the IP. Okay. Right. Now, if we go to the deploy, we'll see that there is only an API service. We have not yet used the OpenEBS provisioner. For this demo, we will not go through the OpenEBS provisioner. We'll just see how the MyAPI service works along with the volume policies. Using these, how we are able to run through the demos. And the first demo will be about the storage pool, how to configure the storage pool, that is the persistent path on which the volume will run its IOs, or where the data will be stored, right? Okay. All right. So what we have to do is now, having installed the operator, we will install this, that is a set of volume policies. Okay. Let's see. All right. So we see a lot of Kubernetes resources getting installed. A bunch of them are related to storage class, and then a bunch of them are related to volume policy. Then there are something called config maps, and at the end, if you can see that that's a storage pool with name SSD, right? Okay. So for the storage pool, we shall be using the storage class called OpenEBS standard, which in turn has been configured to use the OpenEBS policy standard, the one which I have highlighted here, right? And this policy in turn makes use of this set of config maps. So we'll just go to them one by one, right? So keep CDL, get SC if it do, and then OpenEBS, we have a standard, right? So we'll see the description of the standard OpenEBS standard storage class. Okay, among all, we'll scroll down and we see something called this, that's a volume policy. So the storage class refers to this volume policy in its parameters option, right? Now, what we'll do is we will refer to that particular storage policy, volume policy. kubectl get vp. So this was the command that we had seen earlier. It was not working because it was not there by default in Kubernetes. After installing the operator, the volume policies CRD gets installed, and once we run the volume policies YAML, we'll see this set of volume policies that has got created. So what we do is we just browse through the description of this policy, right? So all right, so here in this policy we have got a bunch of policies or a bunch of rules. Some of them relate to monitoring the images, replica image, the replica count and all. However, for this particular demo, we'll be looking at the storage pool, right? How we are setting the storage pool. So this is the way we set the storage pool in the volume policy. So the hierarchy is like volume policy will have a spec, then the policies, and inside the policies we have a name with a defined definition called storage pool. Okay, so the storage pool policy has a value, and the value here is SSD. So this value refers to the name of the storage pool, which again is another custom resource that has been exposed by OpenEBS, right? We will go to that, and before going to that, we will also see that some of the run information. These are nothing but the config maps, the bunch of config maps that got created after running the kubectl volume policies. operation. So, okay, now we'll go to the storage pool. kubectl get storage pool. Again, this was the one which errored out in the basic installation of Kubernetes. The reason was this is an OpenEBS custom resource, right? So we go here, right? So when we get into the SSD, that is a storage pool definition, we see that the thing that is important to us is the path, this particular path information, right? Which in turn refers to /var/myEBS. So this is the persistent path on which the volumes will start running as IO, right? Okay. All right. So till now, what we saw is we saw the storage class. We saw a volume policy. Storage class referred to the volume policy, and within the volume policy, we saw the policy named as a storage pool, which referred to this particular pool, that is the name with the name SSD. And when we get into the description of the storage pool named SSD, we see that there is a path that refers to /var/myEBS, right? Okay. We clear off the things. Okay. All right. So what we do now is we start to create a volume, right? So let's check out one of these volumes. We'll check out the standard one. Okay. Again, this is nothing to do, this specification, the YAML specification that we are seeing has nothing to do with Kubernetes. It is something that is internally understood by OpenEBS, specifically Maya API service. And like I said earlier, the OpenEBS provisioner, which is a dynamic provisioner registered in Kubernetes, that's the one which understands a persistent volume claim, that is a PVC, and creates this kind of spec and provides to Maya API service. What we will do in this demo is we will directly send this spec to Maya API service, okay? And we will see how the volumes get created, right? Okay. So out of all this information, what you can see, the information that we need to see here or is important for us here for this particular demo is this, the storage class. It refers to the storage class with name OpenEBS standard 0.6.0, right? So this is the storage class we had seen earlier. So what we do here is we will send this YAML to the Maya API service, right? And before doing that, we do a kubectl service. Okay, this is the IP on which my API service is listening, right? If you see, if you scroll down, the things that I have been explaining are all explained in a brief in this thing. So what we do is we are at this step now, right? Okay. So what we do is we replace this cluster IP with the one that is mentioned here. Oh shit. Wait, hold on. Copy, paste. Okay. So all right. So what we are trying to do is we are trying to send a request to Maya API service by providing a YAML that is nothing but this particular YAML, the standard YAML, using the cluster IP of the Maya API service, right? Okay. So I'll just clear it out. Okay. So we send the request to the Maya API service. So we already know that it goes ahead and creates some volumes, and OpenEBS volumes are all containerized, and we'll see that a set of pods that has got created. If you see, that volume has got created and it has got. So if you see the deployments, right? So we can see that there is a single deployment called controller, and there is another deployment with the name of suffix with replica. And if you see 1 and 2, that means the design number of counts, the replica counts. We have replica with count 2, and we have a controller with count 1, right? We'll go back to the pods again. All right, we see one is pending, one of the replicas is pending. That's because it doesn't have any node where it can run, and this is a Minikube Minikube setup. However, the purpose of this demo is to see if the storage pool was configured properly. That is a persistent path. And for that, what we need to do is we need to get into the replica specification. We'll pick up one replica. Let's say I'll pick up this one. YAML. Okay. All right. So this is the spec of the replica. If you can see, this is the entire spec of the replica, right? And the thing that we need to see here is the mount path called OpenEBS, which has a name with a /OpenEBS with the name OpenEBS, and we will see what is the host directory on which that is that OpenEBS is using, right? Okay, so here we see the volumes and we see the name OpenEBS. So this is the mapping that we saw earlier, and it has a path like /var/myebs, right? So this is the path which we had configured in the storage pool, right? And which got used, which was referred to in the volume policy. The volume policy in turn was referred to in the storage class, right? All right. So this was the the demo about setting the storage pool, right? We will get to the next demo in a similar way. And okay, so before that, what I do is I will delete the volume.
Hi, Amit. I just had a question.
Yes, Karthik.
So we are seeing this increasingly popular use case in the user community where they want the storage pool to be created on a dedicated set of nodes,
Right.
Where they have the disks of their choice. So that would mean the replica pods also will have to be scheduled there. So is that something that is going to be included in the volume policy going forward?
Okay, so that ideally will not be included in the volume policy. That would be included in the storage pool, right? So storage pool, along with the path, it will also give us a bunch of node information. Okay, let's say the host names, and Maya API service would in turn select those host names, that is the nodes, Kubernetes nodes, and install the volumes on that using the path again, which was specified in the storage pool.
Okay.
Okay. So definitely, when it does that, it will be using the node selector so that the pods are sticking to that particular node.
Okay.
Right. So that is a way we'll be going ahead with.
Okay.
Till the time the storage pool doesn't come up with the intelligence to provide the nodes, what OpenEBS can do is it can taint the nodes, right? It can taint some of the nodes as storage nodes, but then it is expected that the storage pool the storage pool along with this path information should be present in the nodes, right? And that taint information, to tolerate the taint, we can make use of volume policy that tolerates the taint, and which means the pods will be created on those tainted storage nodes, right? So it will be a mix of the things unless and until storage pool comes out with the intelligence of providing a bunch of nodes.
Right, right. Yeah, I think it's a
Amit,
good feature to have.
this is Victor.
Yeah, hi, Vita. Yeah, please tell me.
So extending the same question, so each node can have its own path, right?
That's right.
Okay, it need not be the same path in all the nodes.
Yes, it need not be the same path in all the nodes. Again, it can also have a bunch of nodes or a set of nodes can have same path, right?
Correct.
So all these information can be set in the storage pool, right?
Got it.
So yeah, so there'll be different storage pool which caters to these different requirements.
Got it. Okay. So another question for volume policy, and basically there is one question in the community that IOPS limiting, right? So volume policy can be good place for it to go.
Um, it seems to be a good place. See, okay, so if at all we actually come to a conclusion that we can set the policies on the deployments, the Kubernetes deployments or the Kubernetes pods, volume policy itself will be sufficient, right? However, if we need to do some, some kind of logic, then that logic needs to be built somewhere, maybe in some operators or controllers, or in the MyIPA service. And then that particular logic will be exposed as a volume policy. So volume
Okay.
policy seems to be, currently we are not sure if volume policy itself will be enough, right, for IAPS limiting. It seems to be that it should be sufficient to handle the IAPS.
And from there, it had to be passed to the controllers also, wherever logic gets implemented.
Exactly.
Either through config maps or environment variables, whatever it may be.
True. That's right. That exactly what I was trying to say.
Cool. Thanks, Amit.
Hi Amit, this is Ganesh. I have a doubt.
Hi Ganesh. Yeah.
So, are you using that the scope of the CID is limited to a default namespace, or is it clustered scope?
All right. Great question. So what I'll do is I'll just get through the CRDs. Right. Fine. I think we had not gone through this. These are the bunch of CRDs. Like I said earlier, let's not refer to the storage pool claims now. That is currently been, in progress stuff in OpenEBS. We'll talk about storage pools and the volume policies. So as per Ganesh, he wants to know what scope is it. So we have defined it as a cluster scope. We'll have a look at that. Right? If you see the scope, right? It says cluster scope. This is a CRD definition. The name storage pool, right? It has got an alias name and it has got a scope, and it has also got a version. So when the scope is cluster, so there can be two scopes. One is the cluster level, one is the namespace level, right? As of now, OpenEBS installs these custom resources under cluster scope. So that means we don't need to refer to any particular namespace to use these custom resources.
So you have raised a PR for AutoGen code, right? With the namespace disabled, which we were talking
That's right.
yesterday. So the code, are you trying to watch the SP with the current AutoGen?
No. So the MyIPA service doesn't watch the SP. The workflow is a bit different. If you see, I talked about the storage class, right? The storage class in turn refers to volume policy. Okay. I'll just go through that once again. All right. Okay, so this is a storage class. It refers to the volume policy, right? We'll go to the volume policy. right? So volume policy refers to the storage pool named SSD. So this is the workflow. We are not using the concept of watchers because we have got something called storage class and the volume policy, which are doing the job, right?
Okay.
So that we need not watch for a storage pool. It is being provided to us via the volume policies. And of course, the volume policy is something that the user has to configure. And a volume policy can be used by multiple volumes, right?
So on your code, are you trying to query some CRD, the get
Exactly.
call? So
We are querying. So my API service will be querying the storage pool, custom resource with the name SSD. With whatever name is provided here, that will be queried.
Okay, and you're not passing the namespace there.
That's right. We are not passing the namespace.
And you're still getting the output correctly?
That's right.
Okay. Okay, I'll look at it. Thank you.
All right. So what I was trying to do is I will clear up the setup and I will start running the next demo, which is about monitoring. And again, I want to repeat that I have not configured the Grafana or the Prometheus here, but I want to show the sidecar that can be enabled or disabled via volume policy. So we'll go to that. Right. So what we will do is so we have deleted the volume, and if we do a kubectl deploy, we see that the volume doesn't exist, right? The volume is gone now. If we do the pod, the volume pods are gone. If we do the service, the volume service is also gone, right? So what we will do is we will will run to the I will not tear down the entire setup because again I have to create that. What we will do is we will run the second demo, which is to enable volume monitoring using volume policy. All right. So if you see the bunch of YAMLs present here, I've got a YAML with this particular name, mon on, that is a monitoring on. Let's have a look at what it contains. Right. Okay. So this is again a OpenEBS volume specification understood by my API service. We need to look into the storage class. It refers to something called OpenEBS mon on 0.6.0. This is a storage class name. This is the name of the storage class. We'll go to the storage class now. cdl get sc, get sc, and this is the storage class that was referred in the volume. Let's try to have a look at that. Right. Okay. So the thing that we are interested here is the name of the volume policy, right? So this is the name of the volume policy. We'll get into that. kubectl get volume policy. Okay. Right. Okay. These are the bunch of volume policies, and we are interested into the one with the monitoring on, like this one. Right. So what we do is we do a YAML, right? Okay. So we have come to this. If you see the volume policy, it looks almost similar to the one we referred earlier, which was referring to storage pool. Let us not consider these things now. As for this particular instance of demo, we are looking at the policy called volume monitor, and we see that it has been enabled. It has been set as true, right? So OpenEBS follows the Kubernetes pattern here. The pattern is the volume monitoring, the volume monitoring policy translates into a sidecar, right? So now what is a sidecar? It's a container, right, which runs some logic, and that container is deployed along with a volume controller. So each OpenEBS volume has its own monitoring container, right, which is nothing but a sidecar. And as of today, the sidecar logic exposes the matrix to Prometheus, right? Okay, so this was the monitoring. Okay, this is the volume policy, which refers to the monitoring policy that has been enabled. That is set as true. That means it has been enabled. So what we do now is run the curl command to create the volume. You see here. So before that, I just try to remember the service name. Okay, and I'll run the curl command. Right. If you can see, it refers to these particular volume, that YAML that I was showing, right? And what we will do is we'll replace the IP with the one set here, 110.7.119, right? All right. So a volume has got created. What we will do is we'll run through some kubectl commands to check the same. Right. Okay. This again seems very similar to the demo we completed earlier. Here, let's have a look at the controller. Right. This is the OpenEBS volume controller, and we can see there is something called 2x2. What is that? So here, when we list a pod and we get something called numbers here, 2x2, it refers to the number of containers. Okay, so the pod here, the controller pod has got 2 containers running out of expected 2 containers, right? Okay, to understand further, we'll get into the specifications of the controller. Right. All right. So this is the big specifications. Okay. So if you can see, typically the pod specification for the pod specification has a specification for container, and this is where the container specification starts. It starts with an args, and you give the command, right? You give the command. This is the command that has been given, and you give the image, right? This is the image and other image policies, and you give a port on which that is listening, right? And if you see, if you scroll up further, there is another args, right? So this is an array of containers. So the first container is all about the OpenEBS volume image, which is nothing but the Jiva image, right? We can see the image here, right? And the second container is about the exporter image, right? So this is how a sidecar has got created in the controller pod. And for the applications, for the external applications to refer to this particular sidecar, what OpenEBS has done is it has exposed some of the labels, right? So these are the labels, something called monitoring, and with a value called volume exporter Prometheus, and there are some other things. Yeah, so this is the label. Via this label, external applications can refer to these particular sidecar. It can make use of this label along with, let's say, the name of the volume to select or filter out a particular sidecar, a particular monitoring metric. All right, so what we'll do now, that brings an end to the demo for enabling volume monitoring. We will delete that particular volume before we move on to the next volume. Okay, get go. These are all terminating now, so they will be gone. But as we see, it's not there anymore. If we go to the deploy, it will be gone. Okay, so the volume is gone. What we'll do is we'll quickly go to the last demo, which talks about step 2. Have a steps where we do not want to have any monitoring sidecar. Okay, and let's go through the set of YAMLs present. This is the YAML which seems to be like monitoring off. Let's go to that. Let's check the specifications. Right. Okay. So 1 second. If you see here, there is something called storage class, which refers to the monitoring off, right? This is a storage class that it refers to. Okay. Let me see if it has got. I'm just checking if something got changed in that file. No, okay. So nothing has got changed. That's fine. We'll refer to the monitoring off storage class. In this storage class, we again have a look at the policy, which refers to OpenEBS policy mon off. So we refer to that as well. Right. All right. So here, as expected, we can see the volume monitoring policy, which is disabled, that has been set as false. And so let's create the volume, right? So we'll use the same step that is mentioned here to create the volume. All right, so volume has got created. Let's go and check the status of the pods. All right, so what we see here is, just clear it off, right? Okay, so what we see here is, there is a difference in the numbers here, right? So the sidecar has not got created. The only image that got created was the OpenEBS volume image. That's nothing but the Jiva image. Okay, and let's go and verify that. Verify the specifications. All right, so we have come directly to the containers part, that is, which starts with the args, and we can see it's all about the Jiva. That's a volume. There is no repetition of args here, which means the sidecar has not got created, right? Okay, so this brings an end to the demos that we have proposed in this meeting. We started off with setting up storage pool, how to set up a storage pool using volume policy. Then we saw how to enable volume monitoring using volume policy. And then the last one was how to disable volume monitoring using volume policy, right? Okay, so any questions now, if any?
Amit?
Yes, Karthik.
Yeah, so just for the benefit of the attendees and the community in general, I just wanted wanted to request you to elaborate upon the general use and benefits of the volume policy, because we had the monitoring and uh, replica count and capacity and storage pool parameters specified as part of the storage class earlier, but we now have the volume policies which are defining it in more granular detail. So I think the importance is like to have more granular control. If you want to specify more parameters, it can be specified here instead of in the storage class. So I just wanted you to spend a couple of minutes discussing the benefits of volume policies as against the older approach of just the storage class.
Okay. So, Karthik, just I mean, let me know if I have understood it correctly. You want to know why we have got this volume policy rather than the old way of specifying uh, this, this parameters or key value pairs in the storage class,
Right.
right? Okay, and right. So, okay. So volume policy is something that OpenEBS came up with to make it finely granular with respect to controlling the volumes, right? We expect there will be a lot of controls that will be required by the user when the user wants to operate the volumes. The controls are like one thing. We can specify the controls, let's say from persistent volume claims or perhaps even storage class. However, we cannot expect all these mechanisms to be updatable, right? From the PVCs as well as the storage class, because that is something that is a Kubernetes kind, that is a Kubernetes resource. It has got its limitations with respects to update, uh, with respects to managing the granular policies for a storage, right?
Right.
Kubernetes is getting up with is getting on with some controls, let's say capacity expansion, file versus block, but still even there'll be some kind of redundancies we will observe going forward. But whenever that comes, we'll be making use of the policies given by Kubernetes standard, by the Kubernetes edition. However, we expect these policies will not be, all these policies will not be available in this kind of control, in this finely granular control in the Kubernetes PVCs or even the SCs, right? That is like one point. Second point is if we think about upgrades, as well as updates, uh, we do not find a viable mechanism with the PVC or a storage class. We have to come up, let's say OpenEBS has to come up with its own updates and upgrade policies. For example, OpenEBS is also going with the idea of volume update policy, which is nothing but when an operator wants to disable monitoring from his existing volume, which is already being monitored, it will be done via volume update policy, right? Similarly, if he wants to scale up or scale down, these are not trivial exercises when compared to the OpenEBS volumes. So if one consider the stateless applications, it will be like easily done via Kubernetes, via the Kubernetes existing policies and resources. But when one tries to think about the stateful applications with the data gravity, with the high availability in mind, and with the appropriate um, care that needs to be taken to maintain the data, the underlying data, OpenEBS has to come up with its own set of policies, right? So these are some of the reasons why OpenEBS has moved to its own policies. And these are again nothing to, these has not deviated from Kubernetes way of managing. Kubernetes itself wants the extensions to be done via custom resource, and hence OpenEBS has made use of custom resource for these extensions.
Okay, thanks, Amit. It was very helpful.
Yeah, welcome. Okay. Okay. So, okay, Karthik, you want to give any other updates that is happening in the users channel?
Okay. One thing Amit, that we are seeing is there are a couple of issues that the users are seeing prominently with respect to the volume becoming read-only. So, based on discussions and some tests that we have performed, there are like two cases wherein we are seeing the volumes get into read-only more often. One of them is network disruptions, where we are seeing the controller and replica pods being disconnected for a period greater than the timeout that we've set for both the quorum based read-only presentation as well as the initiator timeouts in the host. The second one is the case where we are seeing the resources are not sufficient on the node where we are running the control reports, especially in cases where extensive IO is being done, which is leading to pod eviction. So we are currently coming up with some troubleshooting guides which should help us rectify this problem, and also for the fixes for these problems, wherein I think this is one of the cases where whatever you were suggesting about volume policies is a good illustration for the use of volume policy, where we can be allowed to set some limits with respect to the resources that are being consumed by our controller and replica pods, which can prevent it from the eviction. So these two are something that something that's being discussed in the users channel. One other thing is from a supportability and a debuggability aspect, how quickly and how efficiently we can capture the logs from the operator and the volume pods when in the event of errors. So as of now, we are making use of some tools in our CI, such as Stern, which is getting the logs of the pods, which is helping us with debugging issues. So the Stern is being run as a binary today on the cube master or wherever we have the cube config. So as per the latest discussions, I think it has been decided to convert this into a debug container which can run the Stern as well as some other utilities to collect logs from the pods and from the nodes, such as other Kubernetes logs, kubelet and kubeapps server logs, etc. So that is something we are coming up with. So this debug container can be invoked as a Kubernetes job. That is the current line of thought, to get all the logs as and when it is deemed necessary. So I think in the coming sessions we should have some increased idea about or we could do a basic demo with the debug container that I'm speaking about. So those are the updates from the community.
Okay, thanks, Karthik. Yeah. All right. So, is there any other questions? Otherwise, we are good to end the meeting now. OpenEBS Weekly Contributors Meeting held on February 16, 2018. So we'll meet next week then. Thank you. Thanks for joining.